Lesson 9, Part to Whole. Our aim today is let's use our knowledge of sector area and length to determine values for the circle as a whole. So in the last lesson, Lesson 8, we were given information about a circle as a whole and then asked to find values like lengths and areas of just the sector, like you see here. Now we're going to be given values for just the sector and asked to figure out stuff about the entire circle. Okay, so 9.1, what's your angle? A circle has a radius of 10 centimeters. Suppose an arc on the circle has a length pi centimeters. What is the measure of the central angle whose radii define the arc? So what I'm going to do, I'm going to draw a little circle. Messed that one up. Ooh, I'm messing up. Let me move them away from the stand. There we go. Alright, not my day with the compass. Okay. Great. Draw my radii. I mean, I really could have just freehanded this, but I had the compass there, so figured why not. So the radius is 10 centimeters. And then we've got some arc on the circle. Who knows how big it is? It could be taking up almost the entire circle, a very small portion. I don't really know. Is pi centimeters. So we got to think about what formula do I want to use if I want to find this central angle. Let's call it theta. All right, so we're given the length of the arc. So if I'm given a length arc, then I'm going to use that formula, right? Where we have circumference, or I guess really arc length is equal to theta over 360. And then the rest of the normal formula we would have for the circumference of a circle. So that would be 2 times pi times r, or just 2 times d if you wanted to use diameter. I'm sorry, just pi times d if you wanted to use diameter. All right, so now we're going to fill in what we know. Well, my arc length is pi units. Theta is what I don't know. And then we've got 2 times pi times 10. So just 20 times pi, really. All right, so one thing I notice here, I'm just multiplying across here. That's the only operation. This fraction times this times this. So I see I have pi on both sides, and I can really just cancel those out. But what you do in actuality is you divide both sides by pi. But, right, that's basically what you're doing. Okay, so what happens when I divide pi by pi? Well, it's 5 divided by 5, 2 divided by 2. All right, all those values are equal to 1. So we get 1 equals theta over 360 times 20. All right, I'm going to separate this fraction, right? This is really 20 over 1. So if I multiply this denominator by 360, I'm just left with theta over 1 times 20 over 360. Because I want to be left with theta in the end. Okay, now I'm going to multiply both sides of my equation by the reciprocal of this fraction here, so they cancel out. So I'm multiplying both sides by 360 over 20. I'm just going to do that on my calculator. So clearly 20 over 360 times 360 over 20, those two are going to cancel out. So on my right side, I'm definitely going to be left with theta. I'm sorry, on my right side. On my left side, I'll be left with 360 over 20 times 1. So I'm going to do the 360 over 20. That's 18. So we get 18 is equal to theta. You could have also multiplied both sides by 360 to get rid of that denominator, and then divided both sides by 20. That would have been 2 steps, but I just decided to do it in one by multiplying the reciprocal of the fraction I wanted to get rid of. So however you see it, either way would have been a fine way of doing this. All right, so we get 18 degrees for our final answer.